Hello friends, here in this video we will see the problem based on force required at the plunger. Here I have a question. Let's get started with this problem. A hydraulic press has a ram of 20 cm diameter and a plunger of 3 cm diameter. It is used for lifting a weight of 30 kN. Find the force required at the plunger. So for this question, since it is a hydraulic press, here I have drawn the diagram of hydraulic press. It consists of ram, which is the bigger diameter end, and a plunger end, which is the smaller diameter end. At the plunger we would be applying the force, and at the ram end the load would be lifted. So basically hydraulic press is a machine which is used to lift heavy loads by applying less effort. Next, in case of hydraulic press, the fluid which we are using, it is oil, as I have shown in blue. Here this is oil filled throughout the chamber. Next, how this operates: whenever we want to lift a heavy load, it is kept on the ram end. At the plunger we are applying a small force. This force is transmitted from the plunger through the oil to the ram end, and finally the load would be lifted. So in other words, in this case, that is hydraulic press, the force is transmitted through the fluid. Now whatever is given in this problem, I will write that in the form of data. A hydraulic press has a ram of 20 cm diameter. So the diameter of the ram, since this diameter is more, I'll keep it as capital D, 20 centimeter. It means it is 0.2 meter. Now once I know the diameter, I can calculate the area of ram. So therefore I'll write down capital A as the area of ram. It will be given by pi by 4 into d square. Here the diameter is 0.2, so pi by 4 into 0.2 square, and my answer of area is, which I have already calculated, it is 0.0314 meter square. Similarly, I will calculate the area for the plunger end. The diameter of the plunger, it is given as 3 cm. So small d, 3 cm. Therefore, it is 0.03 meters. Next, I'll calculate the area of plunger. It will be pi by 4 into 0.03 whole square. And my answer of area of the plunger end, that is 7.068 into 10 raised to minus 4 meter square. It is used for lifting a weight of 30 kilonewton. This load is given. The value of W is 30 kilonewton. It means it is 30 into 10 raised to 3 Newton. This much is the weight which is lifted at the ram end. Find the force required at the plunger. Here we have to calculate how much force is to be applied at the plunger. So that I'll denote it by F, that is the force required at the plunger. This is what we have to calculate. Now with the data available, with the diagram with us, let us try to get the solution for this problem. In the solution part, I'll start it with, since we are having hydraulic press and we know that hydraulic press, it works on Pascal's principle or Pascal's law. So I'll say that since the hydraulic press works on Pascal's law, therefore, see Pascal's law, it states that the pressure intensity in a static fluid means fluid at rest. So the pressure intensity for the fluid in rest will be same in all directions. So therefore, I'll say that pressure intensity at the ram will be equal to pressure intensity at the plunger. This is a very important result of Pascal's law. I can explain it on the diagram that here if we are applying a pressure at the plunger end. This same amount of pressure would be transmitted to the ram end. So I'll say that therefore pressure, we know that it is given by force upon area, and here the area would be area of ram, since we are writing pressure intensity for ram. Similarly, pressure intensity at the plunger will be force applied at the plunger upon area of plunger. Now, therefore, I'll keep force on the ram on one side is equal to area of ram. I have denoted it by capital A. Area of plunger is small a. So therefore, force on the ram will be equal to, here I'll denote force at the plunger by capital F. So capital F into this capital A will get multiplied here, divided by area of the plunger, which is small a. So from this relation, I'll say that therefore force on the ram is equal to, we have capital F, this is the force applied at the plunger, and this is the unknown value. This value we have to calculate. So I'll keep F as it is, into capital A upon small a. Area of ram upon area of plunger we have already calculated. So I'll put the values of capital A and small a. Capital A was 0.0314, small a 7.068 into 10 raised to minus 4. Now, this is the force on the ram, but if we see in the data given that the force acting on the ram can also be made equal to the load on the ram, that is the load which we are lifting. That load value is already given. So it is same as the force on the ram. So I'll say that therefore force on the ram is equal to load lifted at the ram. Now force on the ram we have already found out, it is this value. I'll keep it as it is, F into 0.0314 divided by 7.068 into 10 raised to minus 4. It is equal to, now load lifted at the ram, it is given in the question, the value of weight is 30 into 10 raised to 3. So finally, if I send these terms onto the right hand side, I will get my answer of F. It comes out to be 675.2 Newton. F I have denoted as the force required at the plunger, and the question was find the force required at the plunger. That force we have found out, the value is 675.2 Newton. So I'll say that therefore force required at the plunger is equal to 675.2 Newton. This is our answer. So as we have seen in this video, we have calculated the force required at the plunger for a hydraulic press.